Hi guys, I couldn't really find a good video about Lewis structures. And so I wanted to go through kind of my process on how to draw Lewis structures. Okay, so the molecule that I want to draw is CO2. Okay, so we've got carbon and 2 oxygens, and I want to be able to figure out how to draw this. So first thing, I'm going to go stepwise, is to count valence electrons. Okay, and we already talked about how to count valence electrons in the video that I did on chapter 9, section 1. And so when you look at the periodic table, carbon is in that fourth period. And so it has 4 valence electrons. And oxygen has 6 valence electrons. And there are 2 of them. So 12 total valence electrons. Okay, so total overall valence electrons, we've got 4 plus 12 will give us 16 valence electrons to play with in our structure. Okay, so that's step 1. We've got our valence electrons. And I'm going to kind of do every page a step, I guess. So second step is you want to lay out a skeleton. And that skeleton is the arrangement of your atoms. And so to do this, you want to connect atoms with single bonds. And compact structures are generally preferred over lines. Over lines, like lines of atoms. Okay, so and then the last thing when I'm laying out a skeleton, the skeleton is the least electronegative atom goes in the middle. Okay, and so you can look up electronegativities for atoms, but electronegativity is basically how much each atom likes electrons. Okay, so the most electronegative atom ever is fluorine. And if you go this way on the periodic table or this way on the periodic table, they're less electronegative. Okay, so I'll put less En. And so the atom or the element that's over there is the least electronegative on the whole entire periodic table. And noble gases, like this periodic table I'm drawing, noble gases have no electronegativity. So just kind of ignore them. They don't like electrons. Okay, so if we go back to our original thing, right? We've got CO2, and we want 16 valence electrons. Okay, so 16 valence electrons in CO2. So connect atoms with single bonds, compact structures over line structures, and least electronegative in the middle. So if I look, I've got the choice of a carbon or an oxygen. Carbon is least electronegative, so I put that there. I'm going to attach it with a single bond to an oxygen. And now I have another choice where to put the other oxygen. I can put it on this side by that oxygen, or I can put it over here by the carbon. I know carbon is the least electronegative, so I put it on that side. We'll erase that. Okay, so now I have my skeleton laid out, and I look. I have a total of 16 valence electrons that I can use in my structure. And you guys know every single line right, is 2 electrons. So in the structure I've drawn so far, I have 1, 2, 3, 4. I've used 4 electrons, so 16 minus 4 gives me 12 valence electrons remaining. Okay, so I've got my skeleton laid out. My next step, step number 3, is fill in remaining electron pairs. Fill in remaining electrons. And I want to do that if I can in pairs. Okay, so I've got my structure up here, and I have 12 valence electrons remaining. And so I can go through and I fill my electrons into my structure. Now, the way I decide where my electrons go are 2 ways. The most electronegative atom, right? It's the one that likes electrons best, so it's going to hog the electrons. I'm going to put my electrons around the most electronegative first. And as you guys know, the octet rule, max 8 electrons per atom. Okay, so I need to put my 12 in, and they're going to go on the least electronegative. So, the most electronegative. So oxygen's the most electronegative. So I put 1, 2, 3, 4, 5, 6. Now, this oxygen has 8 electrons around it, so I can't put any more. Now I go to the other side and I put in the rest. So 7, 8, 9, 10, 11, 12. Okay, so I've got 8 electrons around that oxygen, 8 around that. And if you look, this carbon atom has 1, 2, 3, 4 electrons around it. Okay, and that's okay because all of those elements on the first row, boron, carbon, nitrogen, oxygen, and fluorine, they can all have less than 8 electrons. Okay, they can have less, they can never ever have more. They can have less. So step number 4, I'm going to squeeze it on here so I don't have to redraw, is I want to evaluate the structure. Okay, and when I validate the structure, there's 2 things that I look for, right? Like, is this a valid structure? And for it to be valid, I have to A, have the right number of atoms, and B, the right number of electrons. Right, and I'm counting my valence electrons. So I go up to my structure that I've drawn up here, and I'm drawing CO2. So evaluate the structure for CO2. Does it have the right number of atoms? Well, I have 1 carbon atom here and 2 oxygen atoms. So yes, right, I have the right number of atoms. And next I asked, does it have the right number of electrons, right? And to have the right number of electrons, if you remember back from the very, very first step, we're counting valence electrons. And total, this thing should have 16 valence electrons. Okay, so I go through and count, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 valence electrons. Okay, so check, I've got the right number of atoms, check, I've got the right number of electrons. So yes, this structure is valid, okay? Now, here's kind of a catch, I guess, right? Because we don't want just a valid structure, we want the best structure. Okay, so there's two more things that we need to check to see if it's the best structure. Okay, and that first thing is the octet rule. And the second thing is formal charges minimized. Okay, so octet rule, formal charges minimized. And so we kind of already talked about octet rule, right? Atoms want 8 electrons. Right? Hydrogen likes 2, boron likes 6, okay? And boron, carbon, nitrogen, oxygen, fluorine can never be over. But less than 8 is okay. Okay, so when we looked at our Lewis structure for CO2, I'll just draw it up here quick, right? We look at the octets. Does this have 8 electrons? 1, 2, 3, 4, 5, 6, 7, 8. Yes, it does. Carbon we decided was under, but oxygen, the other oxygen has enough. Okay, so there's how we find the octet rule. So next is formal charges. So for checking formal charge, okay, like I said, minimal and few are best. We want to keep those formal charges. Minimal means 0, right? And so we want to try and get formal charges of 0 if possible, but we can't break the other rules. And then another thing about formal charge is they have to add up to the charge on the molecule. Okay, so minimal and fewer is best. We want 0, and we have to add it up, the charge on the molecule. So I'm going to draw this up, and the way I do it is I use the box method. Let's draw our structure that we have so far up. Okay, and so to calculate, I draw a box. And I'm going to draw my box in blue. So I draw it and split that bond in half and go around that oxygen atom, okay? And the way we calculate formal charges is I do the number of valence electrons that we calculated at the beginning minus the number of electrons in the box electrons, and that will give us our formal charge. Okay, so if I look at this first box, right? Oxygen has 6 valence electrons. Remember, I get that from the periodic table. And I count the number of electrons in the box. I've got 1, 2, 3, 4, 5, 6, 7. So see how that bond just counts as 1 electron. It doesn't count as 2 when I'm calculating formal charges. So I subtract 7 from my box, and that gives me a -1. So I have a -1 formal charge on this oxygen. Okay, next I want to look at my carbon. So I'm going to draw, this time a green box, around my carbon. And carbon has 4 valence electrons. And I subtract the number of electrons in the box. So 1, 2 from that bond. Okay, so 2 box gives me a +2. So carbon has a +2 formal charge. Okay, and then the last one is this oxygen. Okay, and this oxygen looks just like the other oxygen. You've got 6 valence electrons, and there's 7 in the box, right? Because there's 1, 2, 3, 4, 5, 6, 7. We subtract those, and that gives us a -1. Okay, so my formal charges, if I take and add them up, I've got -1 +2 -1 equals 0. Okay, so they do add up to the charge on the molecule. If they don't, you've calculated something wrong. You either have too many electrons, you've calculated the formal charges wrong, there's something not right with your structure. Okay, so these numbers are okay, but they're high. Remember, I want to try and minimize my formal charges. I want to try and get these to 0. I can't break those other rules. Okay, so the way I reduce the formal charges is by resonating electrons. So let's write that up here. Reduce formal charge by resonance. Okay, and resonance is moving electrons. And you're going to move those electrons in a molecule from an atom that has a negative formal charge to one that has a positive formal charge. And these atoms have to be next to each other or neighbors. Okay, so let me draw up this structure again. Okay, and I've got, oh, whoops, I don't have one on the carbon, but I have, okay, so here's my structure. On the page before, we calculated the formal charges. This one is a -1, this one's a +2, and this one's a -1. Okay, so I'm going to take and resonate my electrons. So I look at the atoms that have the negative formal charge, which is the oxygens. Okay, and I'm going to pick this oxygen on this side. I'm going to take 2 of its electrons. I'm going to move it towards the atom with the positive formal charge. Okay, and they're next to each other. I'm going to redraw and check the structure. This right here, this double arrow, is a resonance arrow. Okay, it means that between one structure and the other structure I draw, only electrons move. I should have given myself more room, but I didn't. So I'm going to take and draw this structure down here. I've got an oxygen, I've got a double bond to the carbon, I've got a single bond to the oxygen, and then I fill in my leftover electrons that I have. Okay, so I've got a resonant structure. So here's a resonant structure because all I've done is moved electrons. And I have to recheck. Okay, so to recheck, I check the number of atoms. I've got 2 oxygens, 1 carbon, check. I checked the number of electrons. I went through, I checked it earlier, I've got 16 valence electrons. If you go through and count up all the electrons, there's 16 valence electrons there. I checked the octet, okay? So octet here, the oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So oxygen's okay. Carbon is low, and my other oxygen's okay. It also has 8. Okay. So formal charges, again, I draw my box, right? Oxygen has 6 valence electrons. I subtract the number in the box, 1, 2, 3, 4, 5, 6. So that now gives me 0. So the first oxygen has a 0 formal charge. This carbon is 4 valence electrons minus 3 box gives me a +1. And then this one we calculated before is a -1. Okay, so these formal charges are still a little bit high, right? So what we're going to do is resonate electrons again. So let me draw that structure up here. Okay, so I've got my structure drawn. My formal charges are 0, +1, and -1. We calculated them before, right? And we want to resonate electrons. So I'm going to draw a resonance arrow, which says, hey, I'm just moving electrons around, and I'm moving those electrons from the atom that has a negative formal charge towards one that has a positive formal charge. So my new structure looks like this. Okay, so again, my resonance arrow just is says, hey, between structure A and structure B, we're just moving arrows. So now we're going to validate, check again. So do we have the right number of atoms? Right? We've got our carbon, we've got our oxygen, our carbon, our oxygen. Do we have the right number of electrons? Okay, we should have 16 valence electrons. I go through and count. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 valence electrons. Okay, I'm going to check the octet for every single atom. My oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So octets fulfilled. My carbon has 1, 2, 3, 4, 5, 6, 7, 8. So octets fulfilled. And that last oxygen also has 8 electrons. Okay, last thing to check is the formal charges. Okay, so formal charge, draw your box, right? 6 valence electrons minus 6 box electrons gives me 0. So first formal charge is 0. Carbon, we've got 4 valence minus 4 box gives me 0. The last one, 6 valence minus 6 box gives me 0. Okay, so all my formal charges add up to 0, which is the charge on the molecule. The molecule has a 0 charge. So this right here is my best structure, okay? All of the octets are satisfied. All of the formal charges are minimized, okay? So that's your goal right here. Octets and formal charges minimized. Chemists pick sometimes whether they go by the octet rule or by the formal charge rule. And sometimes real life is a combination of both of them. And so as you get more experience, you can kind of make that decision which is better or best, but you have to justify whether you're following the octet rule or the formal charge rule if you have to pick. But your best structure is going to have both of those satisfied. So hopefully that helps kind of walk you through how to draw a good Lewis structure.